Congratulations on installing your new heat pump hot water unit. This video is going to talk you through how to set it up. And it's going to be quite a comprehensive, detailed video because I think if we can spend a bit of time, now that you've got your new unit, setting it up optimally, I think that's going to pay dividends and lead to some efficiency gains for a very long time to come. So let's jump in. So I want to start by explaining how the unit actually works. And if we understand how it works, we can set it up optimally for many years to come. So first thing to understand is how the unit heats water. So this unit, it heats up to 60 degrees. It heats up to 60 degrees because we need to kill off any chance of Legionella, which breeds between 20 and 45 degrees. So the Australian standards are that if it's at 60 degrees for, I think it's about 30 minutes, basically it's going to kill off any chance of Legionella. If it goes up to 70 degrees, it kills it instantly, but most units will heat up to 60 degrees. The water, when it comes out of the taps though, comes out at 50 degrees, and that's because of a tempering valve. Come in and have a look, and I'll show you what it is. So this yellow thing here, that is a tempering valve, and I'll just show you the 60 degrees quickly. So that's the current temperature, 27, but the target temperature is 60. And the tempering valve is another Australian standard, which is required to stop us from burning ourselves. So it drops the water down to 50. So when the water comes out of the taps, it's going to be hot. It should still be hot, but it's not going to be so hot that we're going to burn ourselves. One key thing to understand about the unit and the temperature, don't pay too much attention to it. Now I get a number of customers saying, oh, it says it's only 33 degrees and it's still hot, but it says it's only 33 and it should be 60. Now I'm going to explain how the unit works. Now, we all know that hot air rises. When we've got a heating on, hot air goes to the top and it goes to high ceilings, or it goes upstairs if it's a double-story house. It's the same with water. So here we've got our tank, top of the tank, bottom of the tank. This is hot water from here. This is cold water, and that's called stratification. So the hot water rises to the top. So this is currently 27 degrees, but that point is about here, right? So the manufacturers, they need to pick a point at which to measure the temperature. But it doesn't mean that the water is coming out at 27 degrees because the outlet is here, about there. The outlet's there, you can see the right-hand side outlet. And so that water can still be perfectly hot when it's coming out of the unit. So, but this could all be cold water and that's still hot water. So when the unit's finished and it's run its cycle for the day, and we'll talk about that later, it should all effectively be 60 degrees and you'll have 225 litres. But just because it says it's 27 degrees or 30 degrees on the temperature gauge, which is about here, doesn't mean that you're going to have 27 degree water coming out of the tap. The key thing throughout all this is to make sure you get enough hot water. So the key test is the water coming out hot, and are your showers hot enough? Let's talk about operating modes. Now, a lot of the different manufacturers, including Aquatex, they talk about different modes. They've got about 5 different modes that you can use to operate your unit. I think most people need to worry about 2, maybe 3 modes. Standard mode heats the water up to 60, and when the water drops below 55 degrees, it will kick in and reheat. So standard mode is going to be suitable for the vast majority of us. The other mode that is worthwhile being aware of is eco mode. And eco mode, you can think of that as holiday mode. So whereas standard will kick in once it drops below 55 degrees, eco mode has a different reheat trigger point of 48 degrees. So that means the water needs to gradually lose more temperature before it will kick in and reheat. So if you go away for a night or two, I probably wouldn't worry about changing the settings. But if you go away for more than that, it's worthwhile changing the unit to eco mode so that as it gradually loses its heat, it's not going to kick in so often and we're just going to be wasting energy. The other mode to be aware of is element mode. Now, not all heat pumps, but this heat pump comes with a backup element. And we can think of that as a backup. So hopefully it won't be for a very long time, 15 years or longer, hopefully. The unit has a backup element, which is like an electric resistance element, like the old electric hot water systems that we can use to heat water as a backup. So if the heat pump dies, when the heat pump dies, we've got that backup element to give us some hot water while we get a new heat pump. Okay, so let's get into the detail, and here we're going to talk about a timer. Now, I am a big advocate for setting your unit up with a timer. Whereas our old dumb gas hot water services will just run at any time of the day. It pays to be smart with our smart electric heat pump hot water service. We can set it up to run at specific times so that we are running it for cheaper, cleaner, and more efficiently. Now, I like to run my unit or set it up for what I call the optimal heating mode. And there are 4 factors which I think influence this. The first is solar. So if you have solar on your roof, we obviously want to run it during those hours so we can run the unit effectively for free. Solar doesn't just apply if you have solar on your roof, but it also applies just on a grid scale. I've got another video on our YouTube channel which talks about how wholesale electricity markets work and explains that, long story short, there's a lot of cheap green energy during the middle of the day due to solar, at which we all want to move our electricity usage to the middle of the day so we can use that cheap green electricity as much as possible. The second factor is heat. So this is called a heat pump because it sucks heat out of the air, amplifies it, and then pumps it into the water. So on the left-hand side here, that's the intake. That's where the heat or the air is sucked in. Through here, and you can see the refrigeration pipes as well. And then on the right-hand side is where the cold air comes out. So you might have noticed this with air conditioners as well. You notice there's a cold air coming out. It's really, really cold when it's on heating mode. That's because this section of the heat pump has sucked all the heat out of the air and pumped it into the water, and the output is air with less heat in it. So we want to run the units when there's more heat in the air, and in Melbourne that's going to be around about 3 p.m, but yeah, certainly during the middle of the day. The third factor is noise. So I describe these units as they're not loud, but they're not quiet either. So if this was backing onto a bedroom, which it's not, we want to minimize noise disturbance. We don't need to run it at 10 p.m. And for some customers I've had, they actually work night shift, so we may not want to run it when they're sleeping, catching up on sleep during the day. The fourth factor is your peak tariff. So some customers will be on a peak tariff where they charge more for their electricity between say 3 p.m. and 9 p.m. If that's the case, we want to shift our usage outside of that window. So with those different 4 factors in mind, we're going to have different optimum heating windows for different people. But for the majority of us, a timer between 11 a.m. and 3 p.m. is going to take advantage of solar. There's going to be a fair bit of heat in the air. It's going to minimize noise disruption, and it's going to be off-peak. So we're not going to be slugged more for our usage. Now I'm going to head back upstairs to the computer, and I'm going to talk about how we can think about running the unit on 1 cycle per day and what to do if that's not giving you enough hot water. I wanted to come back up to the computer to show you this infographic, which I think clearly illustrates how we can think about running the heat pump hot water unit for 1 cycle a day. So let's jump in. Let's say at 3 p.m. we have a full tank of, in this case, 270 litres of hot water. We use the hot water in the evening and at night time. Overnight we'll lose a little bit, but in the morning we should still have enough for our usage for our morning showers. Let's say at 10 a.m. the next day, we've got around about 40 litres left. It might be more, it might be a little bit less. But let's say we program the unit to kick in and to restart the cycle. So we use some hot water during that cycle, and by 3 p.m. we've instructed the unit to shut off, but the unit might have actually reached full capacity of hot water before then. But we don't want it to heat any water after 3 p.m. So between 10 a.m. and 3 p.m. the unit is running, and for the other 19 hours a day, the unit is not running at all. It's just holding on to that hot water, and hopefully we have enough. The risk with this approach is that we use too much hot water outside of that operating window. If we use too much for our baths and for our showers, we will run out. And because the unit is on a timer, it will not reheat any of that water. So what I encourage my customers to do, and everyone for that matter, is to set the unit up on a narrow timer for, let's say, 10 a.m. or 11 a.m. to 3 p.m. to start, and then monitor the usage. If you are running out of hot water, again, it's not likely to be in the evenings because we've still got lots left. It's more likely to be, the last person having a shower in the morning. But if you are running out of hot water, then we can go to plan B. And the most obvious plan B is to lengthen that timer. So we can change this to 9 a.m. to 5 p.m. And 9 a.m. to 5 p.m. is still a good timing window because we're still capitalizing on solar, still plenty of heat in the air. It's not really going to annoy anyone with any noise. And for most people, that aren't on peak tariffs, it should still be fine. If you are on a peak tariff, they usually kick in at 3 p.m. So maybe you set it from 9 a.m. to 3 p.m. Now, what do we do if that's still not giving us enough hot water? I think we have two options if we're still not getting enough hot water by a simple lengthening of the timer. So let's call plan C, lengthening the timer again. We can lengthen the timer, let's say 9 a.m. to 5 p.m. is not giving us enough. Let's go 8 a.m. to 6 p.m. Let's go 8 a.m. to 8 a.m. We could do 6 a.m. to 10 p.m. if we want. Now, you can turn the timer off completely as well if you need to. So you can see that there are levers you can pull. However, plan D, I think, is an interesting option, and that's what I call a boost cycle. So what we can do is we set two timers. We have our optimum heating window of, let's say, 10 a.m. to 3 p.m., but then we introduce a boost cycle running the unit in the early hours of the morning. We could run it from, let's say, 5 a.m. to 6 a.m. or 5 a.m. to 6:30 a.m. Now, what that does is it's just giving us a boost to get us through the morning. I don't see much point in running the unit from 7 a.m. to 9 a.m. because that's when we're generally going to have our showers anyway, so we need the water to be warm before then. There's no solar and there's not a huge amount of heat in the air compared to 5 a.m. If we run it at 5 a.m., there's, again, no solar, not much more heat in the air or less heat in the air than at 7 a.m. And it can still sort of do the same job, but it will prime us for those showers that we're about to have. The one key disadvantage with this approach is noise. If the unit is next to a bedroom and that's starting to annoy people, then maybe that approach doesn't work. But it's worthwhile trying it and keeping that in mind. Two other scenarios to consider. Visitors. If we have visitors and they're going to have baths and stay overnight and showers, then our usage is likely to increase. So we need to keep all that I've discussed in mind. The, I guess, most extreme solution is turning the timer off and the unit will just continue to reheat water as it's used. Another scenario to consider is seasons. So in winter, the unit's going to have to do more work because it's colder outside. In summer, less work. Now, we're not going to notice any difference going from winter to summer because it's going to get easier for the unit, but we are going to may notice a difference going from summer to winter. What I would recommend is if you've made changes getting ready for winter, think about reversing those changes as we're going into summer, just to give the unit as much chance as possible to run during that optimum heating window. And you may have overspec'd it if we're still on winter settings. So there's our thoughts on how best to set up your heat pump hot water unit. The two key messages are: one, obviously make sure we're getting enough hot water. Two, don't be afraid to play around with the settings. I do think it makes sense for everyone to start with a narrow timer of 10 or 11 a.m. to 3 p.m. You might find that heating during that optimum heating window gives you plenty of hot water and you never need to change the settings. If it's not giving you enough hot water, don't be afraid to run out a couple of times and change the settings till we eventually get that sweet spot. If you're new to heat pumps, feel free to reach out and have a chat. We are always talking to our previous customers about what settings they're using, are they happy with their tank size, and that real world feedback is invaluable. There are other rules of thumb like 50 litres per person per day, but that real world feedback of what's working, what's not working for customers, that puts us in a really good spot to make good recommendations to our future customers. We hope you have found this video helpful, and as always, we're an open book and always very keen to talk about heat pump hot water. If you're interested in a discussion and recommendations of what might work for you, please feel free to reach out through the website.